How requirement models support each other. As a business analysis trainer, I have interacted with probably 5,000 plus business analysts, and this is one question keeps popping up over time and again. Why there are so many requirements analysis models? Are they related to each other in some way? How are they different? When should we use them? So these are some of the questions that keep popping up in our students' minds, and I thought it's good to have a clear explanation of how requirements models support each other. My name is Ellen Mishra. I am the principal trainer and business analyst at Adaptive US. Adaptive US is one of the world's largest IIBA certification trainings provider. We also provide training on BA skills, data analysis, and strategic analysis. So let me take you through a bit of a journey of requirements models and why they got developed and how should we use them and when we should use them. So first things first, modeling is a diagrammatic representation of some aspect that we would like to represent. And diagrams are always considered better than text because they visually represent things. They are less ambiguous, and it's a good thing to learn because diagrams can express a lot of clear rules which would have taken a lot of time to explain to developers using text, which may remain quite ambiguous as well. Then obviously the challenge with modeling or requirements modeling is there are quite a few of them. As you can see, I have just put 5 of them on the right side, but there are probably many more than that. There are plenty of icons that you can see very clearly, and often these techniques or modeling techniques are discussed as if they have no relationship between them, which is not true. They in fact build on each other. And that's why in this short video, what we would like to understand is what are different kind of models that we can build and how they can support each other. So fundamentally, if we divide or we create a structure for requirements models, there are 3 broad category of models that we can develop. One set of models which can help us to describe features or functionality of the solution that we are trying to build. The second aspect would typically be the structural aspect of the solution, which is mostly related to the information structure within the application. Then there is the third element, which is the flow element of the application, which could belong to process flow, data flow, state flow, or message flow. And again, as we can see here, it is possible to have different set of modeling techniques at a higher level, at a mid level, and at a low level. Like say for example, for the structural model, I have talked of concept model. Below concept model, I have talked of data model, and below that I have talked of data dictionary. Similarly, for process, we could have the lower level as activity model and task modeling. For data as well, we could have context diagram. I think in this side we are talking about data flow diagram. The context diagram is probably on the other side. So we have data flow diagram at level 1, which is also often called the context diagram. Data flow diagram at level 2, one more deeper level, could be at level 3 as well. So now let's kind of get in and try to understand each of these features or models, and when do we use these models when we work as a business analyst. So I will start with first one, which is called the feature models, and in that the most prominent one is called the use cases and scenarios. And in fact today we probably in the agile world we will use user story, but user story I'm not taking it as a model because it does not have any diagramming component. So if you observe use case diagrams, which is what I'm showing you just now, it has a very clear boundary. You can see a system boundary. Then there are external agents who are interacting with the system. Like here I have put one as customer, one as administrator, and whatever falls into the scope of the project is represented as use cases. And of course, use cases can also have hierarchy, can have complex relationships, including include and extend, which is a very different topic that we will cover separately. Then we move to the structural models, and in the structural models, largely we can start with a very high level of data structure, which we could call it as concept model. So as you can see in the concept model, it's mostly business domain related, and we are trying to represent the important concepts in the domain. So for example, here I have tried to represent the concept model for our LMS, which is Succeed, and in Succeed we have courses, we have participants, we have workshops, we have trainers, we have content, and obviously these concepts also have relationship between them, like the trainer develops courses, the trainer conducts workshops. That's how you can relate the different concepts. So from the concept model, you can drill down a little bit deeper and you could start creating data models. And one very popular data model today is the class diagram. And as you can see in the class diagram, from the concept, we have gone down. Here we start talking about classes, which are essentially information storehouses. You can treat it in a very simple term. And the classes have their own attributes and they have operations mentioned on them. And there is of course multiplicity and all, which is again one more level of complexity that comes into class diagram. From the class diagram, you can actually flow into data dictionary, in which, and data dictionary is typically a tabular structure where you explain each of these attributes, their characteristics and so. Then we come to flow models, and in flow models there are different kind of flows that we saw. One could be starting with the process flow models, and that's what we depict is process model, and process models can be flowcharts or can be BPMN diagrams as well. And remember, process models also can be developed at multiple levels. So in the second level of diagram, I have shown activity diagram where we are trying to indicate how a specific process is carried out. And typically an activity diagram will have tasks, will have decision points, could have sub-processes that goes into the activity diagram. Then coming to from activity, we flow to data. And obviously we all know that data flows between various systems, applications, and that's what data flow tries to indicate. So in data flow, again, you have external agents who are providing data or receiving data. So you could start with a very high level data flow diagram, almost representing the entire system just with one circle, and that's what we call it as level 4, level 0 DFD or context diagram. Then obviously, as I said before, the data flow can be broken down. In almost all modeling, we can follow the concept of hierarchy, which is actually extremely beneficial because you don't have to represent everything at one level. You can represent high level stuff, mid level stuff, and low level stuff by following the hierarchy principle. Then we have something called a message sequence diagram where messages are flowing between one object or one system to another object or another system. There we talk of synchronous messaging, we talk of asynchronous messaging, indicating do you expect a response quickly or you don't expect a response quickly. And then we also have state flow diagram or a status diagram, state chart diagram. People call it in many names, state transition diagram, where we are essentially indicating how status of an entity is changing over a period of time. That's what we indicate in state diagram. So kind of summarizing all the models that I just discussed. First, generally you can start with use case diagram because it's at a very high level and that's where we saw actors and features of the system. Then if you want to show detailed process steps, use activity diagram, and that can be very helpful for our business stakeholders. There is actually a technique called use case description, which can be followed up from use case diagram, where we can actually write steps in detail, which can be quite helpful for our tester friends. Then if you want to indicate status of entities in a process or in a structure, you use state diagram. You want to show data flow, then use data flow diagram. You want to describe details of entities, use data model. And if you want to show interaction between various entities, you can use sequence diagram. And if you are trying to describe the details of attributes or information that you hold in the system, data dictionary comes in pretty handy. Hopefully you got some good idea about how these models interact with each other and how we can connect these modeling techniques with one another. If you still have any further question, please feel free to write to us. Our email address is info@adaptiveus.com and the website is www.adaptiveus.com. Thank you so much.